So I want you to imagine a gamer, right? Like someone who spends, I don't know, 10,000 hours mastering a football video game.
Oh, yeah, the kind of person who knows every single glitch in the physics engine.
Exactly. They know every button combo. They can exploit the animation frames perfectly. But, and here's the catch, if you take that same gamer outside, hand them a real physical leather ball, and put them on actual grass,
They completely freeze.
they freeze. They have absolutely no idea what to do. I mean, they've mastered the technique of the simulation, but they have completely forgotten what it actually feels like to kick a real ball on real grass.
It's an incredibly vivid image, and unfortunately, it perfectly describes what is happening right now in the highest tiers of academia today.
Which is exactly what we're getting into. So for you joining us today, we're going on a deep dive into an essay by Matthew D. Corey. It's called Technique Without Number Feeling, on the Late Style of Mature Intellect. And our mission today is to unpack this profoundly unsettling failure mode that's happening, well, among the smartest people on the planet.
Right, we're talking theoretical physicists,
Yeah.
elite economists, top-tier philosophers.
Exactly. We're asking, what happens when the smartest people in the room build a brilliant, highly complex tool to track reality? But over generations, they become so utterly obsessed with the tool itself that they completely forget about the reality you're supposed to track.
And if you're listening to this and wondering, why you should care about the academic habits of theoretical physicists.
Right, like how does this affect my Tuesday?
Exactly. Just think about your everyday life. If you have ever looked at a massive economic policy rollout or, say, read an expert prediction in the news and thought to yourself, okay, this looks absolutely pristine on a spreadsheet, but it makes zero sense out here in the messy, unpredictable real world. Well, this deep dive is going to reveal the exact mechanics of why that happens.
Yeah.
We're going to look at how brilliant minds literally trap themselves inside their own spreadsheets and how that blindness trickles down to affect everything from our money to our technology.
It's basically the gamer syndrome, but with the people who are running our world. So to understand how fields like physics and economics lose touch with reality, Corey traces this exact phenomenon back to a philosophical foundation, one that was laid by the historian Oswald Spengler.
Yes, Spengler is key here.
Right, because before we look at the modern mechanics of this, we really have to understand what is actually being lost. Spengler wrote about a concept he called number feeling. And I'll be honest, number feeling sounds a bit, I don't know, mystical, almost like a superpower. What is he actually talking about there?
It's a great term, actually. Spengler argued that mathematics isn't just some universal, objective language that drops out of the sky.
Hey.
He believed that every major culture has a living, intuitive relationship to math that reflects how they experience the very nature of existence itself.
Wait, really? So different cultures literally do math differently because they experience reality differently?
Precisely. So, for example, take classical antiquity. Think of the ancient Greeks. Their number feeling was entirely based on bounded magnitude. It was very physical.
Tangibly physical.
Yeah, it was sensuous. It was about geometry, statues, things you could actually see, measure, and hold in your hands. But for the Faustian West, our number feeling shifted dramatically. We became obsessed with the infinite function, calculus, unbounded space, this sort of limitless striving.
Oh, wow.
Right. Our math reflected a completely different soul, a different worldview.
Okay, that makes sense. So the math matches the worldview.
Right.
But Spengler made a prediction about what happens when a civilization gets old, right? And I think this is where Corey really picks up the thread.
Yes, exactly. Spengler warned that in the late stages of a civilization, the math doesn't just stop. It's not that we suddenly wake up one morning and forget how to do calculus.
Right.
It's that the living intuition, the soul behind the math, so to speak, calcifies. Spengler says number feeling hardens into number technique. Yeah, the mathematicians and the theorists keep producing incredible results. The technical output is higher than ever, but they lose the intuition of what the symbols were actually for in the first place.
Okay, so the output continues, but the connection to reality fades. Corey actually calls this a decline in aboutness, meaning like the capacity to know what all this complex output is actually about.
Exactly.
Okay, let's unpack this. Because if you look at modern physics or economics, these fields are constantly announcing new breakthroughs. I mean, the journals are absolutely packed. The equations are getting exponentially more complex. The models are producing incredibly detailed results on supercomputers.
Oh, absolutely.
So if they're producing all this output and, winning Nobel Prizes, how can we seriously sit here and say they don't know what they're talking about? Isn't charging these people with having a weak intellect incredibly unfair?
What's fascinating here is that Corey explicitly addresses that defense. He makes it very, very clear. The people operating these advanced models are not stupid.
Right, they're geniuses.
In fact, they're often the most technically gifted, intellectually formidable people their fields have ever produced. Calling it a weak intellect is way too easy and mostly just wrong. The tragedy here isn't a lack of brain power.
So what is the tragedy then?
The tragedy is that their immense virtuosity is entirely misdirected. They are mistaking the apparatus they built for the object it was supposed to serve.
Okay, so it's like, tell me this tracks. It's like they've built this flawless billion-dollar telescope to look at the universe, but instead of looking at the stars, they point it at the ground and spend their entire careers writing 100-page papers about the beautiful arrangement of the lenses inside the tube.
That is exactly it. They become masters of the lenses and completely forget the stars even exist. But to understand how a whole discipline drifts away from the stars, Corey says we need more than just a philosophical mood. We need a physical, mechanical explanation for this.
Because fields don't just drift randomly, right?
Right. The apparatus always drifts toward a very specific place, which he calls the tractable sector.
Wait, tractable? So you mean the parts of the math that are actually solvable? Like they are migrating to wherever the math is easiest?
Exactly that. The tractable sector is the place where closed-form answers live. It's the sector where the math works cleanly, where results can be easily checked by peers, where they can be taught to grad students on a whiteboard, and most importantly, where they can be cited in journals. Yes. Corey calls this overall pattern degeneracy, and he means that in the technical mathematical sense, not as a moral judgment.
Right, meaning a general, highly complex structure loses its messy generality and basically collapses down into a special, highly specific, perfectly solvable case.
Yes. And the really dangerous part is that this mathematical collapse gets mistaken for a profound discovery about the universe.
Oh, I see.
Because the special solvable case is where all the mathematical virtuosity is possible, the field just sets up camp there. They start treating the tractable case not as a simplified, stripped-down model of reality, but as the fundamental reality itself.
This reminds me so much of that classic joke. You know the one, a guy drops his keys in a dark, messy alley, but he's looking for them a block away under a street lamp on the corner.
Oh, right, yeah.
A cop comes up and asks, why are you looking here if you drop them in the dark alley? And a guy says, because the light is better over here.
Yes.
What Corey is saying is that entire academic fields are basically looking for the keys under the street lamp because the mathematical light is better. And over generations, they've actually convinced themselves that the keys must exist under the street lamp.
That is the perfect analogy. And what happens to the dark alley? What happens to the messy, nonlinear, unpredictable real world? It gets quietly reclassified.
Reclassified how?
It gets labeled as a perturbation, a minor glitch, or an annoying little correction on top of their elegant model under the street lamp. They don't see the messy reality as the fundamental truth anymore. They see their elegant, solvable model as the truth, and reality is just an irritating deviation from it.
Which is just a staggering inversion when you really think about it. Now, Corey proves this isn't just some abstract complaint about, like, the humanities. He goes straight for the hardest, most mathematically rigorous science we have, theoretical physics.
Yeah, he doesn't pull his punches.
If this trap happens there, it proves how incredibly insidious the street lamp effect really is.
It really does. And in quantum field theory, the tractable sector actually has a very specific name, the free field.
The free field.
The free field is linear. It is exactly solvable. Its solutions superpose perfectly. Because it's so mathematically neat, physicists built an enormous, breathtakingly impressive technical apparatus on top of it. You see a massive reliance on things like Fock space, canonical quantization, perturbative Feynman expansion.
Oh, hold on. Fock space.
Feynman
expansions. For those of us who didn't bring our quantum physics textbooks to this deep dive today, what are we actually looking at here? Like, how do these tools force a physicist to ignore reality? Break this down for me.
Fair enough. Let's simplify it. Imagine a totally still pond.
Okay, a still pond.
If you drop one pebble in, it makes a nice, neat ripple. If you drop a second pebble, it makes another neat ripple. They pass through each other perfectly. That is a linear system. That is the free field. The math for that is easy and beautiful. That's where tools like Fock space and Feynman expansions work perfectly.
Okay, I'm with you. Pebbles in a still pond. Nice and clean.
But the real physical universe is not a still pond. A real quantum field is self-interacting. It's nonlinear. Imagine a boiling, churning ocean during a hurricane where the waves are crashing into each other, creating new currents, changing the shape of the water constantly.
That sounds significantly harder to measure.
Exactly. The equations that describe a field back reacting on its own dynamics, the real stuff of reality, those are precisely the equations that do not have clean, closed-form solutions. You cannot neatly solve them on a whiteboard.
So physicists a century ago were faced with a choice. Deal with the boiling, nonlinear ocean of reality that they couldn't solve, or focus on the linear still pond that they could. And they chose the pond out of pure mathematical convenience.
Which is completely fine as a starting point. I mean, you have to start somewhere. The problem is what happened next. Over decades, that choice of convenience slowly hardened into a claim about the fundamental structure of the physical world. Physicists started treating the real interacting, messy field as a mere correction to the free field.
Here's where it gets really interesting. Are you saying that physicists literally restructured their belief in what physically exists in the universe just because the math of the free field was easier to grade and publish?
If we connect this to the bigger picture, that is exactly the gravity of the situation. When you treat the real interacting field as a tiny correction to the free field, rather than seeing the free field as a degenerate, stripped-down hallucination of reality, you completely warp the field's ontology. The math literally dictates what you believe is real.
That is wild.
And Corey gives another brilliant example of this inversion in geometry. Specifically, he looks at gauge theory. Back in 1954, two physicists, Yang and Mills, wrote a paper introducing a new field theory. And they didn't use any fancy geometric language at all. It was purely a physics paper about a physical field, self-interacting, with real physical meaning.
So it was grounded in the messy reality.
Exactly. But 2 decades later, in 1975, two mathematicians named Wu and Yang reformulated that exact same physics using the incredibly advanced mathematics of fiber bundles.
Okay, so they took the physics and translated it into this beautiful, rigid geometric arena.
Yes. And the fiber bundle is tidy, it's mathematically closed, it's highly tractable, it has a well-understood classification theory. But then, the exact same quiet inversion happened.
The street lamp again?
Yep. The mathematical community started treating the fiber bundle, the geometric arena, as the more fundamental object. They started acting like the physics was secretly just an instance of the geometry, rather than the geometry being a secondary, rough translation of a physical fact.
Wow, so it's like a musician writing this incredibly wild, raw, emotional song on an acoustic guitar. And then a software engineer comes along and forces that song into a strict, perfectly timed MIDI grid on a computer.
I love that comparison.
Right. It's clean, it's easy to edit. But eventually, the entire music industry decides that if a sound doesn't fit the MIDI grid, it's not real music. They demoted the actual physical field equation because the mathematical MIDI grid was easier to manipulate.
That is a phenomenal way to put it. They imposed the math on the arena before asking if the physical reality actually demanded it. And Corey points out that this same loss of contact with reality happens in probability theory, too.
Oh, really?
Yeah, he highlights a physicist named Edwin Janes, who levied a massive critique against modern measure-theoretic probability, which is often called the Kolmogorov axiomatization.
Okay, lay this one out for me. What went wrong in probability?
Well, Kolmogorov's math is technically flawless. Nobody is saying the formal equations are wrong, but Janes argued that the field became completely obsessed with the infinite case.
The infinite case.
Yeah, measure theory allows you to play with infinite sets, which is highly citable, highly tractable, and generates endless papers. But by obsessing over the infinite limit, they let go of the discipline of tying their math back to finite, physically posed problems in the real world.
When you forget to tie infinite math back to finite reality, you start generating paradoxes, right? The essay mentions something called the Borel-Kolmogorov paradox. What is that like in plain English?
Well, think of it this way. When you deal with infinity, you are basically doing math on a ghost. If you apply limiting operations to infinity without very strict real-world constraints, the math starts to hallucinate. The Borel-Kolmogorov paradox is essentially a situation where, depending on how you set up your coordinates to approach infinity, you get two completely different contradictory probabilities for the exact same event.
Wait, for the exact same event. And instead of looking at that and saying, oops, our math lost touch with reality, they publish it as a deep mystery of the universe.
Exactly. These paradoxes get published and debated as if they are profound discoveries about the nature of chance itself. But Janes points out they aren't discoveries at all. They are artifacts.
Glitches.
They are glitches that happen when you run the machine without asking what finite, real-world problem it was supposed to be solving. The probabilists learned to operate the machinery with incredible skill, but they stopped insisting that the machinery answer to an actual physical state of information.
They lost the number feeling. The symbols don't relate to reality anymore. Now, so far we've talked about physics, geometry, and probability. But if theoretical physicists can accidentally replace the physical universe with a mathematical playground, what happens when we apply that exact same flawed mechanism to something vastly more unpredictable, like human behavior and money?
This is where it hits home. Economics is where the tractable trap becomes highly visible and honestly highly damaging to the general public.
Because it affects all of us.
Right. Corey points out that economics has its own version of the linear free field. It's called the Dynamic Stochastic General Equilibrium, or DSGE model. And at the heart of this model is a concept called the representative agent.
Wait, a representative agent? Like, they just invent one statistically average person and pretend the entire global economy is just millions of perfectly identical clones of that one guy?
Yes. That is exactly what they do. Because if you try to model a population of wildly different people with different irrational motives, different constraints, and different levels of power, the math becomes nonlinear. You can't solve it. But by assuming the economy is made up of these identical, independent, perfectly rational representative agents, the economy magically becomes solvable in closed form.
The street lamp again?
Exactly. You can build an elegant apparatus of optimization, rational expectations. It's mathematically beautiful, and frankly, it's what gets you tenure. And economists treat this degenerate special case as though it is the actual structure of the global economy.
But the real economy looks absolutely nothing like that. I mean, the source material notes thinkers like Thorstein Veblen or Michael Hudson, who argue that this model completely ignores how the real economy actually functions. They point out that the real world is driven by rent capture. It has legally protected structural choke points.
Right.
They argue the relationship between labor and capital isn't some equal exchange. It's a messy, nonlinear relationship of extraction. When you look at an income statement in the real world, it often conceals where value originates rather than revealing it.
Precisely. The real economy is structural, it's messy, and it's full of friction. It absolutely does not diagonalize into a neat equation of independent representative agents. When inflation hits or a housing crisis erupts, the model treats it as a perturbation.
An external shock.
Yeah, an external shock to a perfectly balanced system rather than a fundamental feature of a flawed system.
So let me make sure I'm wrapping my head around this. If an economic model perfectly balances on paper using this representative agent, and it yields a beautiful closed-form solution, but it completely ignores how value is actually extracted in the real world through monopolies and legal choke points, is it just high-level fiction?
According to Corey's framework, yes. Economics has built its most prestigious, award-winning apparatus on a false assumption. They have made the exact same mistake the theoretical physicists made, mistaking the solvable, degenerate case for the world, and then forgetting they ever made the mistake.
And philosophy is doing the same thing, right?
Unquestionably. In modern philosophy, the tractable sectors are things like modal logic and decision theory. They are formally closed, they are highly teachable, and anyone trained in the notation can check your work on a chalkboard.
Right. You can produce these incredibly intricate, logical arguments about possible worlds or bizarre counterfactual scenarios.
But that technical virtuosity has substituted for the much harder, messier question, what actually exists in reality, and why should we trust this formal logic to track it? A perfectly rigorous argument in modal logic tells you absolutely nothing about the real world if its premises were never grounded in reality to begin with. It's a flawless, incredibly complex castle.
Built entirely in the air.
Exactly. Built in the air.
So what does this all mean? Because this really brings us to the ultimate question of this whole deep dive. If we are talking about the most brilliant minds on the planet, Nobel laureates, tenured professors at elite institutions, the people writing the textbooks, if they are so smart, why doesn't the system self-correct? Why do they stay trapped under the street lamp?
Because of the institutional engine. The pull toward the tractable sector isn't just some psychological quirk of being a nerd. It is baked into the social and institutional incentives of modern academia. Think about how a career is made. Peer review, tenure evaluation, citation counts.
The whole publisher-perish machine.
Great. To succeed and survive in that environment, your work must be legible.
Legible, meaning it has to be easily readable, checkable and gradable by a massive bureaucratic institution.
Yes, and virtuosity in the tractable sector is highly legible. A closed-form mathematical solution can be verified by a committee in an hour. But deep, intuitive judgment about a messy, interacting reality, that is incredibly hard to certify. You can't put a number on intuition. Corey brings in a vital point from the historian Christopher Lashier. When a culture hollows out the older, harder-to-fake forms of competence, technical credentialism rushes in to fill the vacuum.
So we are essentially looking at a massive multi-generational filter bubble. You have tenure committees that can only certify what is mathematically legible, and you have a mathematical formalism that only yields closed answers in its most simplified, degenerate limit.
They feed into each other.
Over generations, the institution literally filters out anyone who cares about the messy reality and promotes the people who only care about the spreadsheet.
Exactly. They stop producing and stop even recognizing the rare kind of thinker who insists that the tractable case is always slightly false because it's missing the larger reality. This raises an important question. Where does intellect go from here?
Exactly. If the institutions are totally compromised by this mechanism, what's left?
It's the crux of Corey's diagnosis. If we don't recognize this failure mode, we lose our depth as a civilization. An intellectual culture that was truly mature would look at this late-stage technical virtuosity and call it what it is, calcified technique. It is an impressive achievement, yes, but it is not deep truth.
It's a wildly sobering thought. Just to recap the journey we've been on for you listening, we started with Spengler's idea of losing the number feeling, that vital intuitive connection to reality. We saw how quantum physicists traded the messy, boiling ocean of physical reality for a tidy, linear pond.
Right.
We saw how probabilists got lost in infinite paradoxes, and how economists built pristine models that completely ignore real-world choke points and monopolies. And all of it is kept spinning by an institutional engine that rewards closed-form, legible answers over messy, complex truths.
And as we look to the immediate future, I want to leave you, the listener, with a final thought to mull over, building on everything we've unpacked today. We are currently moving into an era where we are handing over the keys to our critical infrastructure, our financial markets, and our legal systems to artificial intelligence. But what are we training these AI systems on?
We're training them on the models.
Exactly. We are feeding them these exact degenerate models. If our highest human intellectual institutions have spent generations selecting for minds that mistake elegant, tractable models for messy reality, the AI is only going to amplify that blindness by a factor of 1,000,000.
Oh.
Right. If the brilliant humans have forgotten the difference between the map and the territory, the AI won't even know a territory exists outside the spreadsheet. It will ruthlessly optimize the street lamp, and it will entirely ignore the dark alley where reality and humanity actually lives.
Well, if the gamer forgot what real grass feels like, the AI doesn't even know grass exists. It only knows the code. That is a chilling and incredibly vital perspective to walk away with. Thank you so much for joining us on this deep dive. To everyone listening, keep your eyes on the territory. Don't get lost in the map. And always keep questioning those perfectly elegant answers. We'll catch you next time.